Hey, algebra students. Here in lesson 2, we're going to be using a technique that's going to help us for the next couple of lessons. It's called synthetic division. It's something that we've kind of already done before when we were dividing polynomials, but now we're going to be using, I guess, a modified technique that'll make it just a little bit faster. Um, so we're going to be using this thing called synthetic division to do a couple of things. Learning target 4, use it to evaluate a function, and then 5, use it to determine if a number is a zero or a solution of a polynomial. So I guess let's start with this. What is synthetic division? So you're going to essentially omit or get rid of all of the variables. It's not that they go away necessarily, you're just going to not use them. And you can plug them back in at the end if you want. And use the coefficients. So just use the coefficients, get rid of all the x's and whatnot. And then the only thing you got to remember, it's not truly like any polynomial division where we could have divided by any polynomial. Here we can only divide by an x minus something term. Okay, so for instance, like x minus 5. And remember, when we were solving like quadratic equations using the zero product property, it was usually like a factor times another factor equal to 0, and that meant it was the opposite was a solution, and so something like x equals 5 would be the solution. So for that reason, when we do this, we're going to actually be using the opposite of k when we divide. The remainder theorem says this: if we divide by x minus k, like we're talking about before, if we divide by x minus k, then the remainder is f of k. So the converse, meaning the remainder of f of k, is going to be this. And so essentially we can evaluate a function by using synthetic division, and the remainder is going to be our answer to this right here. So instead of plugging some number in for x wherever we see the x, we just do the synthetic division and get our answer. And then the zero of a polynomial. So other words for zero that are essentially synonyms: the root, the solution, the x-intercept. All of these things are essentially the same thing. And so if the remainder like when we talk about up here, if the remainder is 0, then x minus k is a factor, which is something that's going to be important for the next couple of lessons. And so I guess we could also say that k is a root or a solution or a zero. All right, so let's get to some examples here. So here we've just got long division. And this right here is our x minus k. And so k is going to wind up being kind of the opposite of this, opposite of negative 4 being positive 4. And so what I'm going to do is I'm going to just kind of rewrite all of this with no variables. I'm just going to write the coefficients. So 3, negative 2, 0, and negative 150. And I'm going to draw a line down here. I'm just going to bring down the 3. And then I'll just start kind of doing the same division algorithm that we would do normally. 4 times 3 is 12. And negative 2 plus 12 is 10. 4 times 10 is 40. 0 plus 40 is 40. And then 4 times 40 is 160, and that means my remainder is 10. So just kind of like a preview for kind of what we're thinking here. We'd say, is x minus 4 a factor of this? Nope, because that wasn't 0. Is 4 a solution or a 0? No. So, all right, moving on. Here we've got a slightly different looking example. And so if I were to kind of rewrite this out, you'd have x plus 2 and then everything in there. And so negative 2 is going to be the number that I'm going to work with. So I got negative 2, and then I've got my house here. Let's see, so I've got 5, negative 6, negative 28, and negative 2 is my coefficients. So again, I'll bring this on down. I got 5. Negative 2 times 5 is negative 10. Negative 6 minus 10 is negative 16. That makes for positive 32 here. Negative 28 plus 32 is 4. And let's see. Yeah, so then I got negative 8. And so negative 2 minus 8 is negative 10. And again, we can clearly see that x plus 2, not going to be a factor. Negative 2, not going to be a solution because this is not equal to 0. All right, let's branch out and do maybe something closer to our learning targets now that we've got the basics down. It says, let f of x equal this polynomial. Use the remainder theorem to find f of negative 3. Well, that means, again, we're going to essentially, so this has already been turned into it. So x plus 3 would be the factor. And so negative 3 is kind of what I'm working with. And so I'm going to go ahead and set up my stuff here. I got negative 3, and then I've got each of the coefficients. I got negative 1, positive 3, negative 4, and negative 5. All right, so whatever my remainder is down here, that's going to be the answer to f of negative 3. So I got negative 1, negative 3 times negative 1 is positive 3. And let's see, oh, hey, you know what I forgot? There's an invisible thing here that we forgot. So I've got x to the 4th, and then here you'd have 0 x to the 3rd. You cannot skip these. That's going to kind of mess everything up. And so we got the negative 1. We got a 0. We'll slip that in here. Kind of erase that. And we got the 3 here. So 0 plus 3 is 3. Okay, so make sure that you always have something for each one of the terms. It's kind of sneaky in there. So negative 3 times positive 3 would be positive, or I guess negative 9. 3 minus 9 is negative 6. Negative 3 times negative 6, positive 18. Then negative 4 plus 18 would be, plus 18 is 14. Then negative 3 plus 14 would be negative 42, which makes my final, I guess, remainder negative 47. And so we would be able to say definitively that f of negative 3, if we plugged negative 3 in for each x up here, we would wind up with negative 47. And you can see where, if we have a pretty long polynomial, that could be a lot of work. Not difficult work, but this might be a little bit simpler method. All right, final thing here. Decide whether the given number k is a 0 or a solution or a root of f of x. And so what we're going to wind up saying here is, again, we don't have to do the change the sign because this is just the answer. So we'll just go ahead and plop down 1 right here, and we'll go with our coefficients. Doesn't look like we're missing any this time, and so we'll say 1, negative 4, 9, negative 6. And we'll do the same little process. Bring down the 1. And then 1 times 1 is 1. It makes -3. 1 times -3 is -3. That makes for 6. 1 times 6 is 6, which leaves us with 0. And so, is 1 a solution or a 0 or a root to this polynomial? And well, because the remainder was 0, we can say yes, absolutely it is. All right, next one, just for fun, maybe you want to pause the video and see if you can do it on your own. We've got -1 right down here, and then it does look like we're going to need to throw in a 0x to the third. So I've got 1, 0, 1, -3, and +1. All right, so again, if my remainder is 0, it's a solution. If it's not 0, anything but 0, it's not a solution. So I bring down the 1. -1 times 1, -1. And then -1 times -1, +1. Now I got 2. -1 times 2 is -2. -3 minus 2 is going to be -5. -1 times -5 is +5. And so my remainder is 6. And since 6 is not 0, we can say that no, this is not a solution. So this in and of itself, synthetic division, not necessarily a huge complicated thing, but it is definitely a necessary tool that we're going to be using for the next couple of lessons.